Hey, welcome to the Explainer. So today we're going to tackle a really big topic in AI, something you hear about all the time, quantization. And you know what? We're going to break it all down using one simple, kind of fun metaphor to make it all just click.
And this right here, this quote is basically the key to understanding everything. It's the whole philosophy behind quantization summed up perfectly. The goal is never the smallest scarf, it's the most faithful cut. Okay, so what on earth does that actually mean? Let's get into it.
All right, to really wrap our heads around this, I want you to use your imagination for a second. Just picture it. What if a huge, super complex AI model, with billions and billions of parameters, wasn't just a bunch of code and numbers, but it was actually a magical scarf? All right, section 1, the AI scarf. So what exactly is this thing we're talking about?
It's actually super simple. The scarf, well, it is the model. Think about it. A 7 billion parameter model? That's just a scarf that's like 7 billion little stitches long. But here's the thing. Its length isn't what makes it special. Nope. It's all about the pattern. That incredibly intricate design, that's the model's intelligence. It's every single connection, every little weight it learned when it was being trained.
Okay, so we've got this beautiful, super intelligent scarf. Why in the world would we ever want to take a pair of scissors to it? Well, it turns out there's one really, really big practical problem. And that problem, it's sheer size. A full precision 7 billion parameter model, our original uncut scarf, comes in at a whopping 28 gigabytes. I mean, that is just huge. It's not going to fit on the graphics card in your gaming PC, that's for sure. So to put it simply, this amazing scarf is beautiful, yeah, but it's totally impractical. For most of us, just trying to use it is slow, it's expensive, and a lot of the time it's just not even possible. But let's take a closer look at that pattern, right? It's not just some random jumble. It's actually made of these repeating sections, or cycles. And inside each of those repeating parts, you can usually spot 3 different things. You've got the really important foreground designs, the stuff that catches your eye. Then there's the less important background fill. And finally, you've got these rare but super critical little accent details. And this is where we get to the big aha moment. What if a huge chunk of that super intricate pattern is just, well, background fill? The stuff that adds to the size but contributes almost nothing to the design you actually notice. I mean, if we could just get rid of that part, we could make the whole scarf way smaller without really hurting the way it looks. And that idea right there brings us to the solution. This is the whole art of quantization. Or, in our metaphor, we can call it the art of the consistent cut. So what is quantization? It's really all about one simple rule. You find that part of the pattern you don't really need, that background filler, and you cut the exact same chunk out of every single repeating part of that pattern, all the way down the scarf. It's that consistency that's absolutely key. That's what makes the whole thing work. And you can see the payoff right here in this table. You know those quant levels we're always hearing about, like INT8 or INT4? Well, that's really just a label for how much of that original pattern you decide to keep. The original full detail pattern cycle, that uses 32-bit numbers, what we call FP32, to describe its 32 little parts, or weights. But if you can simplify that down to just 8 weights, boom, that's INT8, and your model is suddenly 4 times smaller. And if you go even further, down to 4 weights, or INT4, now it's 8 times smaller. It's a really direct relationship. But here's a really important point. How you make that cut is just as crucial as the fact that you're cutting it at all. This isn't just about hacking away at the material, It really takes a tailor's skill. Think of it this way. On one hand, you've got the naive tailor. They just chop. It's kind of like just rounding off all the numbers without thinking. And if you do that, you risk cutting right through one of those important designs. But then you have the skilled tailor. They use smart algorithms like GPTQ or AWQ to really study the pattern first. They find that background fill and they cut there, making sure to preserve the beautiful design. So how does a skilled tailor actually study the pattern? Well, there's a process for that, and it's called calibration. It's basically like laying the entire scarf out flat under some really good lighting. You do this by running 100 or so sample prompts through the model. And what that does is it shows you the real range of all the weights, so you know exactly where the important can't touch this motifs are and where all the boring cuttable background stuff is.
Now, every once in a while, a part of the pattern has this totally unique, one-of-a-kind detail. Maybe it's a little bit of gold embroidery that appears absolutely nowhere else. In the AI world, we call these outlier weights. They're pretty rare, but they are incredibly important. A skilled tailor knows you can't just apply your standard cut here. No way. You have to be super careful and cut around these special accents to make sure you preserve them. Okay, so when it comes to actually making the cut, there are, broadly speaking, three main strategies for when and how you do it. First up, you can just cut the scarf after it's already completely woven and finished. We call that post-training quantization, or PTQ. It's super fast, super convenient. The second way, you can weave the scarf from the very beginning, knowing exactly where the cuts are going to be made, and you adjust the pattern as you go. That's quantization-aware training, or QAT. This gives you the absolute best results, but man, it is expensive to do. And finally, there's a third way. You can cut some parts on the fly in real time as the scarf is actually being worn. That's called dynamic quantization. So let's bring this all together. How does this translate to the real world when you're on a site like Hugging Face, about to download a smaller model? Well, it all comes down to finding that faithful cut. Okay, so when you go to download one of these quantized models, you're going to see these weird labels in the file name, right? Usually in a format called GGUF. Well, now you'll actually know what they mean. A Q80, that's just a standard one-size-fits-all cut. Pretty simple. But what about something like Q4_K_M? That is the work of a skilled tailor. That tells you it's a pretty deep cut, but one that was made very carefully to protect all those important accent details we were just talking about. Which leads us to probably the most important question of all. After all this slicing and dicing, did we actually succeed in preserving the beautiful pattern? Or did we just end up with a smaller but totally ruined scarf? The way we actually measure this is with something called perplexity. The easiest way to think about it is that it's the eye test for our scarf. It's a score that tells us how well the smaller quantized model can still do its main job, which is predicting language. A nice low perplexity score means the design is still gorgeous and completely intact. It means the seams from our cuts are basically invisible. And this really gets to the very heart of the trade-off here. Look, you always lose something when you quantize. It's just a fact. Some tiny little detail, a subtle color gradient, something is lost. So the really crucial question isn't, did we lose anything at all? It's, did we lose anything that a real person using this model would ever actually notice? And that brings us right back, full circle, to where we began. You see, making a model smaller, that's the easy part. Anybody can do that. But making it smaller while preserving its intelligence, its unique pattern, its very soul, that is the art. And that's why the goal is never, ever just the smallest scarf. It's always about the most faithful cut.